So please follow those projects. Next, I would like to invite to the stage Vicky and Paul of Boredomresearch, and they worked together with a consortium called SubCULTron, and they've been doing a lot of experiments here in Austria. But eventually, you're going to do some diving in the lagoon of Venice. We don't know. Okay. So tell us. And give them a hand, please.
Okay, thank you. Okay, we're really happy to be here. It's our first time at Ars, so thank you for inviting us, Lucas and Eric. Most of you will know Boredomresearch for producing simulations on natural behavior and movement. So, for example, this piece here that we produced some time ago called Lost Calls of Cloud Mountain Whirligigs, where we've created a simulation of virtual creatures and the environment that they live in and inhabit. And one of the reasons why we like creating simulations is that you can change the movement and behavior of your creatures. You can also change the physics of their environment as well, and that's very easy to do.
So we're working with SubCULTron, which is looking to establish a community of robots that live in a heavily human-polluted environment, which is obviously quite a challenging environment. And for us, that's a huge kind of leap out of the virtual into dealing with the real world. So we've spent some weeks in their labs in the University of Graz, in the Swarm Robotics Lab, kind of dealing with real-world challenges like building things, physical things, and trying to get over the fact that we can't really change the physics of the universe. We just have to find solutions. So we did try using baby oil, but that's another story. So we've kind of, it's been fantastic. We've spent 2 weeks working with an electrical engineer, and our experience has kind of been, well, can we? And then the engineer says, well, first we need to download the data sheet and check the specifications. And we're thinking, well, we're only here for 2 weeks. Can we just throw it in and see what happens? At first, electrical engineers find this really disturbing. But over the 2 weeks, Joshua, who we've been working with, kind of got really into this sort of very spontaneous, fluid way of working. And we arrived at this space between art and electrical engineering, which we would call visceral engineering. Okay.
So SubCULTron have been producing robots that are developed at a very high specification because basically they're going to be putting them in Venice Lagoon. So they're dealing with human polluted environments. So they have to be engineered to a really high specification so that they can be robust and withstand the depths that they're going to in the water as well. But when we were in the lab, they were telling us about how some of their initial tests they do in jam jars, so just like glass bottles. And we were really interested in this because we thought, wow, like using household waste to actually produce their tests. So, and we saw this as being really relevant to our current situation with environmental crisis as well. So we started to work with the SubCULTron team in Graz to produce these robots that are built out of human plastic waste.
So this is us kind of testing the motion dynamics of microcontrolled plastic rubbish. And we've been thinking, well, what can we learn from these simple plastic robots? And for a start, one of the things, our plastic robots had these tendrils made of plastic bags, and bits would break off, and they would end up swimming in a plastic soup of their own detritus, which would get trapped in their propellers, and we realized that this would kind of interrupt their life cycle. We have this kind of life cycle which they need to return to the base to recharge, and this would interrupt that, and they would die. And suddenly it kind of, we realized that, well, this is the fate of much of our marine life. So there's a very strong connection between the robots that we're building suffering the same plight as a huge amount of our marine life. When we started to think, well, we needed to program in a kind of a death sequence, a last gesture that our robots could make when they realized that their fate was doomed. And this got really confusing in the dialogue we was having in the lab. And we kind of realized that maybe robot death is a bit of a taboo from an engineer's perspective, but it's something that we're quite keen to pursue.
Okay, so we did lots of tests. We put our robots in a tank of water and watched how they responded. And one of the things that really appealed to us with these plastic tentacles that we were playing around with, and some had plastic bags attached to them, that they were really beautiful. They had a really beautiful movement. And it made us realize that actually working in simulation is a really hard thing to achieve, this kind of intoxicating movement that we were getting from these robots.
So the simple adornment of plastic bags gave them a biological signature, and it suddenly kind of made very apparent there's the same problem that much of the marine life has, where it mistakenly eats plastic. I think a recent Australian study showed that 90% of seabirds contain human plastic waste, and that these organisms, they can't accommodate the sudden changes in their environment. And it seems also that us as humans, we can't seem to adjust our behavior in acknowledgement that this wonder material is also quite harmful and damaging, hazardous substance. So a direction at this point is to build plastic robots made from human waste that are designed to live and die in plastic soup. So that's...
And then on that note, we're going to invite Alex up to...
Wow, that's teaching your researchers team about dystopian design. Alex, please come to the front, and you have some very good questions in mind.
Do we get a chair? Hi, I'm Alex May. I'm an artist also from the UK. I work with robots and code, and I write all my own tools and installations and things, and tools for other artists. And I've had the pleasure of knowing these two for quite a few years now. So I sort of, I wanted to pick up on obviously the robot death thing, because that isn't obviously a common thing, and it sort of hasn't been a common thing in your work either. I mean, you've gone from using real live animals like real snail mail, which had babies and things, and was all very nice, and then you've modelled real life creatures in the springtails, as well as doing sort of very abstract, like the whirligigs kind of thing. But even in those pieces, I don't think they ever die, do they? They sort of fade out and sort of disappear?
Yeah. The whirligigs died in a very nice way. In the code, the method that was called when they were no longer required was they were instructed to go for a long walk, at which point they would fly to a distant location outside of the view of the camera before being instantly removed from...
We have known in real snail mail, I mean, it doesn't happen, this has only happened once, so any human animal rights people out there, it doesn't happen very frequently, but we put a copper fence around the table so that detracts the snails from going over, so it keeps them in the garden. But often they like staying in the garden anyway because it has loads of veggie matter and stuff that they like nibbling on. But there has been a case where they kind of breached the fence, and I think they were trying to get over, so one of the snails did actually pass away on the fence, didn't it? But that's the only time where people have actually witnessed our creatures sort of dying. And it was something that really interested me in the lab, because one of the reasons I chose SubCULTron is they said they wanted to work with long-term autonomy. And when I started to question some of the researchers in the lab about this, I said, what's the longevity of your robots? And they actually said, we engineer them so that they can last up to a week. And for us, that's such a minimum time, isn't it? Because it's...
That would make quite a short exhibition period.
Well, I was going to say, yeah, it's not even an exhibition, really, is it? Now, I know, Paul, you've been wanting to work with robots since childhood. Is that right?
I think we produced a work in Springtown. When was that? 2004. Yeah, and I think then we had a notion at that time that it would be great to build them as physical objects, but never quite. We've been very comfortable working in the safety of simulation.
It's very comfortable, yeah.
So far, yeah. But maybe that will change.
Well, I mean, that was my experience moving from the sort of virtual to back into the physical, was how difficult it is and how you are affected by the laws of physics.
Yeah.
And it's
interestingly, we've been working with a mathematical modeler who works in the field of epidemiology, and that's very much kind of science at the interface between simulation and then trying to understand how then to intervene in the real world with positive interventions. And that's been fascinating for us to understand how bizarre and abstract their simulations and representations are, that then they have to use in a useful way that's meaningful in a real world context. So one of the things that's been really interesting for us is just to make those steps into understanding how different things are when you're dealing with physics.
But I mean, it was interesting, especially given your artistic practice, that the SubCULTron team, their robots are actually mimicked after real life things. There's lily pads and fish and mollusks or mussels. And you were saying that they quite want it to look more natural.
Yeah, well, it's interesting because they have to be engineered at such a high standard, they have to be so robust that they've kind of gone for a streamline kind of look, which is very quite clinical. So they're mussels that are going to sit on the seabed. They don't look anything like natural mussels. They're more like submarine kind of cylinders. But yeah, they did say when we're in the lab, the biologists were sort of saying, and they're a little bit frustrated with that, they would like them to look more biological, which was interesting. So obviously, where we were in the lab and we were attaching plastic bags that looked a bit like tentacles to the robots, they actually some of the engineers started to get quite inspired by this, and they were thinking, oh, what other materials can we work with, which was really rewarding for them as well, I think.
Also, it's another interesting kind of just link or something that's joined up with another project that we're working on is a lot of their work deals with the control of robots, and we were in discussion about these very simple crafts that would just have one ability to rise and fall, but then the way they rise and fall allows them to move around, and you can have very sophisticated emergent behavior coming from this really quite simple behavior. And we have another project dealing with freshwater pearl mussels, where we're soon to go to a research facility where they have large collections of pearl mussels, and they record their movement over time. So we're we kind of get to join up research from different projects that we're engaged
Paul,
with.
can you speak a bit louder?
Yeah, sure.
It's difficult to hear because of the acoustics here.
Right. Okay.
Yeah.
Sorry to interrupt. I just wondered, did you cover it at the beginning about what it is the scientists actually are trying to achieve with the robots?
So they're looking to establish what they call a culture of robots living in the Venice lagoon. And for us, there are some kind of disturbing interpretations of culture. For one, we find it a little bit, we're uncomfortable with the idea that they have these separate, isolated communities of what they refer to as mussels living under the water. And you can transfer their culture, if you like, their way of doing things from one group to another. and from some higher control mechanism, if one is seen to be preferable, it will eradicate or overwrite that existing culture. So they're looking from a very kind of a functional engineering perspective of what gives the scientists the data, the best, the most useful information. But we're kind of interested in introducing maybe more human ideas of culture into that way of thinking about autonomous robots.
And I just wanted to finish off with sort of, would you say, have the scientists kind of learned things from your involvement with the project? Are you sort of, affecting them, steering them a little bit?
Okay. Well, I think our throw it in and see what happens has been, and it's we've found a really nice middle ground where we recognise that if we don't read some of the data sheets, things do burn. But Joshua, the electrical engineer working with me, when we left, he said, this has been such a fantastic experience for me. It's completely changed my outlook. And I think that's just this much more open and spontaneous way of working that's completely outside of the culture that he's used to.
I think also primarily it's a lot to do with the aesthetics as well, because obviously they're dealing with simple rules in nature, which we're also inspired with to have a look at the complexities from those rules. But a lot of the time it's just simulating what's out there in the natural world, is not perhaps taking it one step further and thinking about the aesthetics of that and how we can frame it and the kind of wider story that we can tell through these kind of algorithms and rules that they're applying. So I think they've learned a lot from that in regards to the thinking about how they can project some of those rules and algorithms into something that has a more meaningful experience for people.
Thank you very much.
Thank you, Vicky and Paul, and thank you, Alex, for doing the interview.